Welcome to Gast Ed. Today we will be discussing how to deploy scalable AI applications using Claude Code. Look, this isn't about those basic chat interfaces or simple web experiments that just disappear the moment you close your browser. This is about fundamentally upgrading your operational leverage. It's about building robust internal systems that actually scale right alongside your business. By the end of our time together, you're going to understand how to construct an enterprise-grade digital infrastructure from the ground up, utilizing artificial intelligence not as some novelty, but as a core operational asset. To get there successfully, we're going to follow a rigorous architectural roadmap. We'll start by defining the local AI paradigm, move into establishing a unified workspace, explore multi-agent systems, set up our database architecture, and finally lock in the deployment pipeline. Let's dive right into Phase 1, the local AI paradigm, moving beyond prototypes. We really must shift away from fragile, consumer-level web wrappers and instead establish a secure, localized environment natively on your machine. Think about the limitations of standard web-based AI platforms for a moment. They function a lot like a construction crew building flat-pack IKEA furniture. The results are fast, sure, but they're entirely rigid and confined to a specific system. You get what comes in the box, and nothing more. Claude Code, however, operating locally on your computer, acts as a dedicated in-house architect. It doesn't just wrap around your project, it actually lives inside your local folders. Because it operates internally, it retains deep corporate memory. This is critical. It remembers your exact branding guidelines, your previous coding mistakes, and your highly specific folder structures so you never have to repeat yourself when requesting an update. The operational advantage of this shift is profound. Running AI natively on your desktop means you can completely bypass and replace those clunky legacy automation tools. It can autonomously generate complex JSON data, which is simply the standard, lightweight language modern web applications use to communicate behind the scenes. By generating this locally, it executes commands directly inside your local folders and adapts to your internal workflows seamlessly. You are essentially granting the AI the authority to physically build, alter, and manipulate files locally, saving you and your team countless hours of manual file management. That brings us to Phase 2, the unified workspace, establishing your infrastructure. We need a proper, integrated development environment where our new AI architect can actually operate and execute its tasks. Enter Cursor. Cursor is a unified workspace that seamlessly integrates your raw codebase with advanced context-aware AI capabilities. Think of it as the central command center for your entire deployment operation. What makes this so highly valuable for business owners is that it bridges the gap between management and development. It allows even a non-technical manager to visually oversee and converse directly with the AI as it writes code, dramatically lowering the technical barrier to entry. To set up this bare-metal infrastructure, we have some strict directives. First, you've got to install Node.js, which is simply the underlying engine that lets your computer run JavaScript outside of a web browser. Next, you'll use your computer's terminal to download the AI agent natively to your system. Finally, you must designate a master project directory. This is a specific, isolated local folder where all operations will be contained and executed. It acts as a secure local vault for your digital workforce. Once your environment is set, you establish a global instruction file. By creating a master markdown document right in your directory, you literally force the AI to memorize strict corporate standards. Imagine telling a human developer to always use your company's specific hex color codes, or to always format text a certain way. Well, this file does exactly that, permanently, across your entire project. The agent functions as a genius developer, natively absorbing these global instructions and flawlessly applying them to every single file it touches, ensuring complete brand consistency without any manual oversight. Moving on to Phase 3, multi-agent systems, scaling your operations. Here, we're moving well beyond single-task automation and entering the realm of highly specialized automated workflows. To truly quantify the raw power of this system, you've got to understand context capacity. Every individual agent you deploy has an enormous 200,000 token context window. That equates to approximately 150,000 words of memory per agent with absolute retention. To put that business value into perspective, it's the equivalent of handing an agent a 300-page operational manual and knowing it instantly memorized every single comma. This capacity is what enables a highly scalable multi-agent architecture. You can have one core project agent orchestrating your high-level tasks. That core agent can then independently deploy specialized sub-agents. For example, you can spin up a dedicated UI designer agent and a separate idea validator agent specifically instructed to critically analyze your concepts. The financial impact here cannot be overstated. You are effectively spinning up entire digital departments, design, QA, and development, without the overhead of traditional payroll, all operating with zero context dilution. To maximize the return on this architecture, you want to feed these agents your entire corporate memory. Upload all critical business logic, target audience data, and operational guidelines directly into the workspace. And let's address a common fear right now, data privacy. Because this is a local workspace running entirely on your machine, feeding it your proprietary corporate memory is completely secure and isolated. It's not at all like pasting sensitive internal logic into a public browser window. Every specialized agent perfectly understands your exact business context before it executes a single strategic task. Let's move to Phase 4, Database Architecture, Isolating Data for Scale. Look, a beautiful front-end application is functionally useless without secure relational back-end data management. For this back-end architecture, we utilize Supabase. Supabase functions as an enterprise-grade, secure relational database. If that sounds overly technical, just think of a relational data ledger as a highly organized, interconnected spreadsheet system living in the cloud. It securely handles your user logins, isolates dynamic data, and acts as the scalable backbone of your application, ensuring that as your user base grows, your infrastructure doesn't collapse. The integration logic here is straightforward and highly efficient. Inside your unified workspace, you simply feed the AI your database project URL and a secure anon key. That key acts as a specialized digital passport, allowing your local AI to safely talk to your cloud database. Once authorized with this digital passport, the AI can independently generate relational tables, populate them with test data, and sync live user metrics directly from your localized application up to the cloud, all without you needing to write a single complex database query. Which brings us to our final step, Phase 5, the deployment pipeline, from local to global. We've built our app, we've secured our data, and now we must securely transport our localized corporate infrastructure out onto the live web. This deployment flows through an exact 3-step operational pipeline. Step 1, your localized code sits secured on your machine. Step 2, that code is pushed to a GitHub repository, which is simply a highly structured, version-controlled storage center for your application's source code. Step 3, a hosting platform like Vercel connects directly to that repository to render the code as a live, publicly accessible website. By utilizing this exact pipeline, you completely remove the need for manual server management, a complex process that historically would have required a dedicated IT professional on staff. Security protocols during this transition are strictly non-negotiable. When moving code from a local desktop environment to the public web, you must manually conceal your database credentials. You extract those raw credentials from the codebase and isolate them securely inside Vercel's environment variables. Think of environment variables as a hidden encrypted vault that keeps your sensitive passwords completely detached from your readable code. This ensures your data pipeline remains untampered and entirely secure from public view. The return on investment for building this specific automated pipeline is massive. Because your hosting platform and your code repository are directly linked, any localized change your AI architect pushes to the repository, and this is the critical part right here, triggers an instantaneous automated deployment to your live web app. Your digital infrastructure continuously updates in the background. There are no manual file uploads. There are no drag-and-drop hosting requirements. It's an enterprise-grade standard of continuous, automated delivery. The strategic imperative moving forward is entirely clear. Modern AI is no longer just a novelty chatbot summarizing emails. It is a true business asset capable of constructing, managing, and deploying enterprise-grade software from the ground up. The question you have to answer as you assess your own operational leverage is this: will you continue to rely on generic, rigid AI tools, or will you invest the time to build your own scalable, automated infrastructure? That is all for today. If you enjoyed this video, please remember to like, comment, and subscribe.